So next is how to determine the regular payments of an annuity. So once again, we're going to compare our two types of calculations, our present value calculation versus our future value or our amount of an annuity. Recall that present value is used to determine the money needed at the beginning of an annuity to provide regular annuity payments. So for example, making monthly withdrawals or payments of $1,000 for the next 10 years. And recall, future value is used to determine the accumulated value of the regular payments at the end of an annuity. And for example, making monthly contributions of $1,000 into an account for 10 years. So the next question is, let's say I want to borrow $20,000 and I want to know how much I need to pay per month over the next 5 years to get down to $0. Or let's say I want to start an account where I make regular payments over several months until I reach my goal of $20,000. So what we're going to try to figure out next is how do we get this regular payment that we need to make? And here are the formulas that we're going to need. These are just modifications of our original formulas. So for present value, if I want to figure out the regular monthly or weekly payment, I'm going to take the value of the loan, times it by the interest rate, and divide by 1 minus 1 plus I to the negative n. If I want to figure out the regular payment in order to save some money, I take the amount that I want to save, times it by the interest rate, and then divide it by 1 plus I to the exponent n minus 1. And these two formulas will give me the regular payments I need to make. The variables are still the same. PV represents the present value, A represents the future value, R represents the regular payment, I represents the interest rate per compounding period, and N represents the number of compounding periods. So let's go through some examples and try to identify which of the two formulas we will need to use. So example 1. Joshua borrows $25,000 to purchase a car. He will repay the loan in equal semi-monthly payments over 5 years. He is charged interest at 4.8% per year, compounded semi-monthly. How much is Joshua's semi-monthly payment? So first of all, we see that this is a loan and that he has money right now. So this is going to be a present value calculation. So since I'm trying to determine the semi-monthly payment, I'm going to use the formula for R, which involves the present value, so that's PV times I, over 1 minus 1 plus I to the negative n. So next, let's state our variables. So we know the present value, that's the total value of the loan, is $25,000. The interest rate is 0.048, and since it's semi-monthly, that means twice a month. That means we're going to have to divide this by 24. So that gives us 0.002. And then the number of payments we're going to make is going to be 5 years times 24, which gives us 120 semi-monthly payments. So next part is to sub in our values. And then use our calculator to determine the regular semi-monthly payment. Please ensure you put the brackets in the correct locations. And I end up with a payment of $234.54. So next part is how much interest will Josh pay? First of all, let's figure out how much he pays over the 5 years. So we know he pays $234.54 twice a month for 5 years. So remember, that is our end value, which was 120, which gives us $28,144.80. And we know that Josh borrowed $25,000, which means he paid $3,144.80 in interest. So again, this is the amount of money on top of the loan that he will need to pay over the next 5 years. Example 2. Alex plans on buying a car in 4 years and he needs $25,000. He can save money at a rate of 4.8% per year, compounded weekly. What is his weekly deposit? In this scenario, we're going to see what happens if you save your money and then go and purchase a car for the full price. So in this example, we notice we're saving money, so this is a future value calculation. And that means we're going to use this version, R equals A times I over 1 plus I to the positive n minus 1. We have our amount we want to have in the future, which is $25,000. We have our interest rate is 0.048, and since it's weekly, we divide by 52. So we end up with approximately 0.0009238. And then we have the number of weekly deposits, which is n. So we have 4 years times 52, which gives us 208 weekly deposits. So let's sub these into our formula. We end up with $109.08 each week. Finally, how much interest will Alex earn? So we know at the end of the 4 years, he'll have $25,000. And he put away $109.08 every week for 208 weeks. That was our end value. So he ended up putting away $22,688.64. So that means Alex made $2,311.36. So instead of paying the full price of $25,000 for the car, he ended up buying it for $22,668.64 because of the interest he earned by saving his money first. Try the following questions.